In most microservice architectures, each service operates independently. This means that when one microservice gets a request, it doesn't remember anything from previous requests or anticipate any future requests. It simply does its job and sends back its response. But there's a number of use cases where having a bit of memory or context between calls could be really useful. So you might want to store some data in between calls to microservices. So to do this, we can use volumes. So for example, if we wanted to have a counter, so we want to add a method to our microservice, every time we call the method, it will return how many times that method's been called. So how might we do that in Spring Boot? So to do that in Spring Boot, I'm going to add an additional method, counter, and I'm going to give it a get mapping /counter, and I'm just going to create int counter equals 0, and I'm going to add one onto the counter and return string value of counter. So I'll pull up a web browser and navigate to localhost 8085, which is the port we're running on, and counter, and there we have one. If I reload the page, it's counting up. So that's as we would expect, but microservices are designed to be stopped and started, and also they're designed to have multiple replicas of the pods. So we can't really expect this pod to persist throughout the life of our microservice. So if I would just stop this and start it again, I think you know what's going to happen. The program's restarted, so the counter's been reset to 0 and we're back to 1. So what we might do about that is we might save it into a file. So in my application properties, I'm going to save a value counter file, and I'll call that /data /counter.txt. I'll make a directory in my current directory here, new folder data, just the folder there, and then I'm going to get the value of that counter file in my controller, private string counter file name, value. Okay, so I've modified my counter method to take in the counter file name from the application properties there, and then the counter method is going to read the file. If there's an exception, I'm going to assume that the file doesn't exist or it doesn't contain an integer, and the counter will just be reset to 0. I'm going to add one onto it, and then I'm going to write the value back into the file. So now I've got my data folder. Now if I run this application, pull up a web browser and visit counter, we've got the counter working there, but if I restart the application, it carries on working there, because in the data folder we are saving the string value of the counter there. So how do we do that in Kubernetes? So we need to define a volume, and there's various ways we can do this, but the simplest way is an empty directory volume. So I'm going to go into my YAML, and I'm going to redefine in the application properties in our config map, counter.file. We'll just have the /data /counter.txt. And then I'm going to define a new volume. I'll name it just mshw.volume, and I'm going to make it the simplest type, an empty dir volume. And then in my volume mount section, in my deployment, I'm going to say name MSHW volume and mount path /data. So that is the mount path to the application. So when we do /data /counter, it's going to have an empty directory, and that's going to be mounted as /data, so we can write into the file there. Now I'm going to rebuild my application, so maven install, run as maven install. Just check in the target folder that we've just rebuilt MSHW main jar, which we have. So I'm going to rebuild my Docker image, docker build, and just do Docker images to confirm that the image was built, which it was. So now I'm going to do kubectl get namespaces. I'm going to delete everything which is in the MSHW namespace. That takes a few seconds to do, and when it's complete I'm going to reapply my YAML. I just need a capital P in mount path there, so reapply the YAML, and we are deployed. So now if I pull up my web browser, go to mshw.com/counter, you have an error. Now it's working. So there we are counting, and now if I go into the pod, so I can do kubectl get pods in namespace MSHW namespace, and using that pod name, kubectl exec interactive terminal in the pod name, in the namespace MSHW namespace, and we want bash. Now I'm inside the pod. If I do ls, we can see we have a data directory, ls data, we have counter, and if I cat data /counter, we have the number there. So that is working as it was in our development environment, with a file that we're saving data /counter.txt to remember the counter. So now if I come back later, the counter should still work. But what happens now if we shut down the pod, because the data directory is in the pod? I'm still inside the pod, just get out of there, and kubectl scale deployment MSHW deployment replicas equals 0 in the namespace MSHW namespace. We've scaled our deployment down to 0 replicas and then back up to 1 replica. So in other words, I've just restarted the pod. Now if I reload, we're back to counter of, well, the counter's reset. So that's not ideal, because in Kubernetes pods are designed to be scaled up and scaled down or restarted if they crash. So we're not really persisting the data here, we're just persisting it in that instance of a pod. Now also, if I scale up the replicas to 3, then if we just wait until they're ready, so kubectl get pod, now we've got 3 running pods. Now the behavior should be a bit unpredictable. So we have 1, 1 again, 6, 2, 2 again, 7, 3, 3, 8. So it looks like the load balancer is giving us, it's cycling through the pods, giving us the 3 different pods, and each different pod has a different value for its counter. So we're not really getting the effect that we want there. So in case it's not clear what's happening, we've got our data file inside our pod. We've now got 3 pods, and so we have 3 counters, 1 for each pod. So we're persisting data in the pod, which is not really what we want, and it's pretty useless really. So another type of volume we can define other than the empty dir volume is a host path volume. So all I need to change is in the volume definition, I could say host path and define the path /mnt /data. Now the mount path that we're using is the one defined in here, so we can put any path in there. It's just going to get defined from our application. It's going to appear as if it's /data. So I'll just do path /mnt /data and redeploy. I haven't changed the application, so I don't need to rebuild. I can just apply the YAML, and that will convert our volume to a host path volume. Now we're back to 1, 2, 3, 4. If I scale back the pod down to 0 and scale it back up to 1 and reload again, the counter keeps working. And if I scale up the replicas to 3 replicas, the counter keeps working. So what we're doing now, we're using a file on the host, which is the node, instead of a file in the pod. So all 3 pods are sharing the same volume, and that volume is a directory on the host node. So it's working, but it's still not ideal. The file's contained on our Kubernetes node on which our pod is running. In my setup, I've got a single node Kubernetes server running on Docker desktop, so it seems to be working. But in a production Kubernetes cluster, there's likely going to be more than 1 node, possibly with pods distributed around the world on different nodes. So the best way of doing things is to use a persistent volume. Now, there's various ways you could do this, but in the next video I'll show you how to do it with a Linux network file system server. We'll set up a persistent volume and do the job properly. But for now, thanks for watching.